Hey guys, today we're going to be cleaning up the Precision Matthews, and I'm using my shop vac with my 5-gallon Cyclone system I built a couple of years ago. It works really well for collecting up all these aluminum shavings so that I can recycle them. Today we're disassembling the mill here, and I'm going to be mounting my X and Y axis so that I can make sure that they fit well, and also find the location of the ball screw in relationship to the saddle so that I can take some measurements and make some ball nut mounts. This whole disassembly process went fairly well. I've done this a couple of times already, so I'm getting pretty good at it. The Y-axis is bolted up real nice. All the holes lined up. I was really happy with the overall mount. As you can see, the saddle clears real nice, got plenty of room there. I'm finishing up here with the X. Alright, we got our X mounted, and we can see how our length turned out. You can just see we have maybe a 1/16 of an inch there before we hit our shoulder, so that was really perfect. Very good. That turned out really nice. Alright, so we've got our X-axis on, and it'll allow us to get this much more travel here. If you remember, I was talking about how I relieved this so that we could get a little extra travel there. You can measure that. 1.25 inches, just as I thought. So I'll pick 1.25 inches up this way. And then of course, it will be the same as hitting right here. It's just a little bit bigger than our cavity right there. So it looks like I'm going to have to shave that down across there, which will be fine. There's some room up top because I'm able to twist it. But regardless, I was going to have to do something either way, so now probably if I would have went with the 16mm ball screws, I wouldn't have needed to do that. But I think this mill deserves the bigger screws, so we'll see how it goes. Alright, so we'll get this all figured out. And I think I'm not going to mock up the Z-axis quite yet. Pretty sure it's going to fit just fine. Overall, I think turned out pretty well. Alright, so now let's get our measurements and figure out how we're going to do our couplings. Okay guys, so what I've got here is one of those just magnetic bars that you hang your tools on and stuff. And I've got it stuck up under here where it's just touching the bottom of this ball nut. And what I did was, I took my calipers and I just measured down from the top of the X table with my calipers here. Measured down from the top until it touched this bar, and I did that on both sides, and I kept moving the bar until I got it even, and I came up with 69.5 millimeters. So I know that the bottom center portion of my ball nut is 69.5 millimeters down from the top of the table. So what I'm going to do now is I'm going to measure down from the top of the table to the bottom, or to the top of the saddle, where the ball nut mounting block is going to be mounted, and then that will give me, with that measurement, I should be able to figure out where exactly this is going to be above my saddle, and then I'll be able to draw up a mount. Okay, so I've taken the X mount off. Ball nut has got to sit on this pad here, or the ball nut mount, I should say. So the ball nut has got to slide in there like so. Now this right here is a little low because of this hollow, but it gets shallower up here. So this will fit up under there nicely. What we need to do So what I want to do is I want to measure from the top down to this pad, and I want to take that measurement and subtract it from the measurement we got just earlier and see where we're at. So I'm going to measure beside each hole. Okay, we look like 68.6. .6. Let me double check that. Okay, 68.59 here. .6, okay. Okay, so 68.6, and then the other measurement was 69.5. So we're looking at about 0.9 millimeters. So that's not very much. It's less than a millimeter, which is about that much. So that's how much space we're going to have between the top of the pad here and the bottom of the round part of the ball screw. So now that I know that, I know about how much, how big the ball nut block's going to be. So I'm going to take those measurements, and then we'll transfer it over into Fusion 360 and draw something up and see what we come up with. Before I put the mill back together to machine the ball nut mounts out, I want to do some measuring on the y-axis and see what we can come up with there. So let me get this back together, and we'll move over to the y. Okay, so here is the stock location of how far the saddle goes back in the Y direction to this line right here. And what happens is, this is the ball nut for the Y-axis, and this just goes up in a hole in the bottom, like so. And then that's as far as it'll slide forward, because it hits the casting here. Now we're going to be going with ball nuts, and I'm also going to be going with a ball nut carrier. Basically the same thing. I'm going to put a knob on there, we're going to shoot a screw through there, and that's going to hold our ball nut mount. And so our ball nut's just going to slide in a mount. It's going to have that nub up under there that's going to bolt to that. And I want the ball nut to be at least flush with that, because I want to get as much travel in this direction as possible. problem with this setup is that we need to try to address is clearance right here, because the ball nut needs to clear that. So in the stock position, in order for me to maintain the stock travels, this needs to, the ball nut needs to come to about right here, and that'll give me the stock travel. But I want to try to extend it a little bit, and also I'm going to need clearance for my ball nut to go in. So we're going to try to relieve some of this casting right here so that we can get some more travel and get clearance on our ball nut. Alright, so I've been doing some ciphering here, and it looks like, well, let me just show you what I got here. So here is the center line of my spindle, right here. Here is the stock position when the y-axis is all the way back with the stock screws. This is the stock position that the saddle sits right here. And at this spot right here, you got 8.5 inches of travel. And the way our ball screws are going to sit in here, like this, we can only go back to this line right here because the thickness of the front of the casting here is about 15 millimeters. So we can only go back to here. So with the double nut ball screw, this is the furthest travel that I possibly could get. So I marked the max travel line right here. And then I figured out how much overhang I was going to have. I'm going to have 3 inches of overhang at max travel. Or excuse me, 3.5 inches of overhang at max travel. That would probably be okay. But I don't really like the fact that the ball screw is going to go all the way back up against this casting. So I kind of decided that, well, I'm going to be putting a spacer right here on my spindle, and I don't want this spacer to be thicker than maybe an inch. So I think that if you go, I've seen them, 2 inches, but I just feel like you got to lose some rigidity that way. So I don't really want to go more than a 1-inch spacer. So what I'm going to do, since I know I'm only going to go 1 inch, I'm only going to be able to push this line out 1 inch to move the center line of the spindle. Then I'm only going to be able to get 9.5 inches this way. So therefore I'm going to need 9.5 inches this way. And I think 9.5 inches is a good amount of Y travel. I'm working with 4 inches now, so having an extra 5.5 inches is over double what I'm using now. So I think I'll be just fine. So what I'm going to do is I'm going to push my ball nut back to here, and that will be my new max travel. And you can see I still have a good inch of space right here before it hits the casting, so I'm feel pretty comfortable with that. And by pushing the line out to here, it's going to give me 10.5 inches from the center line to the end of the table here. But if I push this center line out 1 inch, then that gives me the 9.5 inches of travel. So that's kind of how I came up with all these measurements. This is the route that I'm going to go with, and I think 9.5 should be fine. Actually, it's going to be a little bit over 9.5, but I wanted to get a little play in there. So now the material that I'm going to be using to mount the ball nut is 32 millimeters thick. So I've got to relieve this cutout here in order for this to be able to get to its full extent. And that's what this is right here. Now you may notice that, why didn't I go all the way to here? Well, there's a actual thickness right here is thinner than this. This kind of tapers like this on the edges right here. So it's real thick. And then right here, between here and these two lines, there's actually a cutout that goes like this. On the bottom side, it's actually a recess, and that's for a clearance, I guess. So I want to keep the maximum amount of thickness I can on the table here. So I'm going to just cut out what I need. And I'll drill a hole in each corner so they'll be rounded, and then I'll just take a ziz wheel, a cut-off wheel, and just cut that, notch that out. And also the top right here of the ball nut, excuse me, is going to hit this casting right here. I have 7.8 millimeters of clearance, but I need 9.98. So what I'm going to do is I'm going to have to relieve that with a grinder. I'll just kind of go like this back here with a grinder underneath and just kind of relieve that. And I'll show you some video of that when I get to that point. But I'll just take a die grinder or cut off wheel and just kind of thin that out just a little bit. I'm not going to go all the way through because I want to keep as much material here as possible, but I'll just from underneath just kind of grind that out back to this line so that my ball screw has clearance right there. Also right here, I took and slid this up and then marked the exact center location of this hole. The reason being is this right here didn't look very centered. When I got to looking at it, I'm like, that just doesn't look right. I mean, you can kind of see how the castings are on this Chinese made stuff, but it just didn't look right. But actually, I think it is lined up. It's just an optical illusion because the thickness over here versus here. However, I wanted to double check, and after looking at it, I think what they did was maybe slid this over and bored this hole because it's dead on where the spindle line is. And that also, that center line right here also coincides with the center of this hole right here, and that's where I lined my ball screw up on. So I know that this is going to be dead center, and so I'm going to reuse this hole in order for my ball nut mount, and I think that should be fine. But if we move this back to our max travel line, which will be right there, and then the ball nut will actually be a little bit less than flush with there, and it'll have the mount right here underneath. So that's how that'll kind of look. And you can see how much overhang we're going to have. This will have 3 inches sticking out, and then over here we'll have 4.5 inches remaining. And I think that that's well over half. So I think that as far as rigidity, I'll be just fine. And as I said before, it's going to give me about 10 3/4 from the spindle to the edge of the Y table or X table here. It's about 10 3/4. So if I put a 1-inch spacer in there, it's going to push it to about 9 3/4, and I'm shooting for 9.5 inches. So you can see that 9.5 inches of travel is going to be plenty. I think we're doing good there. What I'm going to do now is I'm going to go into Fusion 360 and draw up these ball nuts mounts, and I'll shoot some video on that. Thanks for watching the video. Please feel free to ask questions, make suggestions, and leave comments. Thumbs up if you like the video. Please subscribe to the YouTube channel. Thanks for watching, and most importantly, be safe.